Okay, 1.1 is a review of some topics. It's really from different sections of pre-calculus or college algebra, a bit of trig, graphing. We start off with a review of difference quotient formulas. There's two of them. This is the one that you're used to, and this is the new one they're going to use in this book when we get to the derivative and definition of a derivative. The goal here is to eliminate the h in this difference quotient formula and to eliminate the x minus a in this secondary difference quotient formula. They're both representing average, but when we get there, I'll elaborate on the theory and how that works. So for each function, evaluate both of those and simplify the answer. Well, let's see. If I start with the difference quotient for this, f of a plus h, that would be f of a plus h would be a plus h squared minus 2 times a plus h minus f of a minus, make sure to use parentheses, f of a is simply a squared minus 2a all over h. The goal is to eliminate h out of the equation. If I FOIL that, that's a squared plus 2ah plus a squared minus twice a minus twice h minus a squared plus 2a all over h. I underestimated the spacing on this. There we go. So those two cancel out and those two cancel out. We notice the three remaining terms all contain an h, and if I cancel this out, I'm left with simply twice a plus h minus 2. Now, I'm not sure if I'm going to be able to fit that. I doubt it. But for now, let me go ahead and figure out what is f of x minus f of a over x minus a. Well, f of x is simply what you see, minus, make sure to use parentheses, f of a is really a squared minus 2a. So here, if I look at x squared minus 2x minus a squared plus 2a over x minus a. The goal here is to factor. If I group those two, that's x squared minus a squared, that's x minus a into x plus a. And what I have left is minus 2x plus 2a over x minus a. That would be x minus a into x plus a. Factor out a negative 2. I'll have a positive x minus a over x minus a. Now, if I look at those two terms, if I factor out x minus a out, I will have from this piece x plus a, and from this piece or this term a minus 2. And I notice that those two cancel out and I'm left with x plus a minus 2. Okay, the spacing was a bit off, so I underestimated how much space that needs. Same deal, we're going to do this now. And what we want to do the difference quotient, f of a plus h minus f of a. So let me write that down. Okay, let's give me more space. Here we go. So if we go by f of a plus h minus f of a all over h, that would be a plus h over a plus h plus 2 minus f of a, which is a over a plus 2, all divided by h. This is a complex fraction, So I'm focusing on the three main functions that you see from algebra, and of course trig is a different story. The way it works, the LCD for the top and the bottom combined would be both of those. So what's this missing to have the whole LCD? Again, the LCD for the top and the bottom combined is a plus h plus 2 times a plus 2. This is missing just the a plus 2. You multiply top and bottom by that. That becomes a plus h times a plus 2. This is missing the a plus h plus 2. Multiply top and bottom by that. You have a negative a times a plus h plus 2. And the denominator is missing both of those. So that's h times a plus h plus 2 times a plus 2. And that would be an a squared plus, I'm foiling those, 2a plus ah plus 2h. Distribute the negative n, minus a squared minus ah minus 2a, all over h times, and I know it's a bit messy, but keep in mind what we want. We want to cancel this original h, which is right there. And you notice the a's cancel out, those cancel out, and those cancel out. You're only left with this. You're only left with 2h over h times a plus h plus 2 times a plus 2. And if the h cancel out, pretty much you're done. And when you get to derivatives, they're going to ask for an alternative form, which is the next form that I'm doing. And if I wanted to take this function and figure out what is f of x minus f of a over x minus a, well, f of x is x over x plus 2. F of a is a over a plus 2 over x minus a. Here the goal is to cancel that denominator. Again, complex fraction. The LCD is x plus 2 into x plus into a plus 2. So in this case, this is missing an a plus 2 minus a. This is missing an x plus 2, and the denominator is missing both. The reason I don't distribute the denominator out, I'm trying to get rid of, the purpose is to get rid of this term. So keep that in mind. That is ax plus 2a minus ax minus 2a. Cancel out. And if I factor, I think I messed up somewhere. I canceled the wrong things. Getting excited there, right? Those two cancel out. If I factor, oh boy, okay, something's not right. Let me just make sure I'm seeing this. Ax plus 2a minus ax minus 2a. Found it. It's right there. It should have been ax plus 2x, and this is a negative ax minus 2a. There we go. So yes, those cancel out. If I factor a 2 out of that, I'll have an x minus a. And those cancel out. And I'm left with a 2 divided by x plus 2 into a plus 2. Again, a bit tedious. I love that part. Okay. X plus 2, and that would be my final answer. And if I take a look at the last type of problem, and these are the three types of problems that we see all throughout this course. And if I see a radical, that's the third type of problems that we're going to deal with. If I take f of x plus h minus f of x all over h, that would be the square root of x plus h plus 2 minus the square root of x plus 2 divided by h. The goal is to eliminate the h in the denominator. Well, the only alternative here to get rid of it, since there's not much you could do, is to multiply by the conjugate. I know you're used to rationalizing the denominator. Here you have to adjust. It's not what you've been doing all along. It's what do you need? You need to get rid of h. And if you have a radical and you simplify as much as you can and there's not much you could do, then the only way is to multiply by the conjugate. Now the denominator is a big mess. Just bear with it and drag it along. Remember, we don't distribute the h because we want to cancel that. Otherwise you have to factor that afterwards. That's counterproductive. I don't know why I'm writing so small. I have all the space that I need. Here we go. Now for the top, when you multiply conjugates, right, you get the first squared, that cancels the radical, minus, make sure to use parentheses. Did you notice that? That's happening on every combination of these type of problems. And might as well minus x minus 2. And what do you notice? The 2's cancel out and those cancel out. And what are you left with? You're left with h over h times the square root of x plus h plus 2 plus the square root of x plus 2. And once that h cancel out, you would know that you are done. And that would be my final answer. Now if I would run ahead and write the second form, f of x minus f of a over x minus a. Again, keep in mind I want to cancel this. Well, f of x is simply square root of x plus 2. F of a is simply a plus 2 over x minus a. Again, I simplified, and if there's not much to do and you're dealing with a radical, then you know exactly what to do. You multiply by the conjugate of the radicals. That makes those very predictive, which is really good. So I see a radical, I should keep in mind, most likely I'm going to multiply by the conjugate. The denominator, you just copy down those. You don't distribute, you don't FOIL, because you're going to cancel out that. Plus square root of a plus 2. The denominator, I'm just going to drag with me, which is the annoying part. The top, I'm going to get the first squared. That cancels the radical. Minus, again, use parentheses, the second squared. So that is x plus 2 minus a minus 2 over x minus a into the square root of x plus 2 plus the square root of a plus 2. The 2's cancel out, and you'll notice I have x minus a, and again, it's not really magic, it's math, how that happens every single time. And I'm left with 1 over the square root of x plus 2 plus the square root of a plus 2. Okay, I'm going to shrink this a bit again. And there it is. Now, these answers don't look the same because when we learn later on about limits, you're taking different limits. So those don't have to be the same. They look somewhat the same, but they're not exactly the same. Now, second topic we start with, probably I'll start that in the next video,